2019 paper for CAPE Mathematics Unit 2. So let's get into it. All right, so this is module 1, question 1, and it says let 4x squared plus 3xy squared plus 7x plus 3y equals 0. Show that dy by dx is this. So let's go ahead and differentiate this function. So to differentiate this function, of course, we're going to have to use implicit differentiation. When we differentiate 4x squared, what we're going to get is 8x plus 3xy is product, so we have to use product rule. So we keep the first, which is 3x, multiplied by the derivative of the second. When we differentiate y squared, we get 2y times dy by dx, which is y prime, plus we keep the second, which is y squared, times the derivative of the first. The derivative of 3x is 3, plus when you differentiate 7x, you get 7, plus when you differentiate 3y, you get 3 dy by dx, or you can call it y prime. And now that is equal to 0. Before you even do this step, make sure you told them that you are differentiating both sides. Differentiate both sides with respect to x. With respect to x. Right? It's good that you state to tell them that you are differentiating both sides with respect to x. So now all we need to do now is make y prime the subject. So anything with y prime, we keep on one side. 3 times 2 is 6, and so this can be written as 6x y times y prime plus 3y prime. It's going to be equal to, we are going to bring over the 7 over here, bring over the 8x over here, and bring over the 3y squared over here. So bringing over the 8x, it's equal to minus 8x. Bring over the 3y squared, it is now minus 3y squared. Then bring over the 7 over here, become minus 7. Nice. Now all we need to do is factor out y prime from this expression. So we factor out y prime. Factoring out y prime out from here. All we're left back is y prime from 3y prime is just 3 plus y prime from this 6xy leaves just 6xy. And so y prime times 3 times 6, 3 plus 6xy is equal to, we can factor out the negative from here and write minus of, factoring out the negative, we're left back with 8x plus 3y squared plus 7. This is what we are left with. And so what do we do now? All we can do now is divide through by 3 plus 6x, 3 plus 6xy. And so that means that y prime is equal to minus, in bracket, 8x plus 3y squared 7. We divide it by 3 plus 6y, but 3 plus 6y I can factor out a 3. So I can factor out a 3, and I'm left back with 1 plus 2xy. That's how you do this question. Nice and easy, soft. Remember that y prime is dy by dx. All right, so this is shown. Soft, the capital T, soft. right, so that takes care of question 1, part 1. Now, let's have a look now at question 2, part 2. It says, show that for f of xy, which is equal to 4x squared plus 3xy squared plus 7x plus 3y, show that this is true. I'm going to rewrite what this is saying. This is saying show that 6 times, this is dou f by dou y. I like to write it as the function being differentiated with respect to y. So we need to show that 6fy minus 10 is equal to dou 2f of dou y squared, that is fyy. So I'm just rewriting it in a way that I prefer to see it. fyy times dou 2f of dou y dou x, meaning you differentiate with respect to x first, then with respect to y. So that is f differentiate with respect to x first, fx, then with respect to y, that's fxy, plus, this is now dou 2f of dou x squared. I'm going to rewrite it now, that is just fxx. So this is what we're trying to prove. If this is what we're trying to prove, first we need to do is start with f of x. This is f of x. From f of x, we're going to find the partial derivative of f with respect to x. Differentiating it with respect to x, we get differentiating 4x squared, we get 8x. Then differentiating 3xy squared with respect to x, we get 3y squared. And then differentiating 7x with respect to x, we get plus 7. So that is fx. All right, we're going to need to find fy along the way. So let's find fy right here. Fy would be equal to, this is fy, differentiating with respect to y. When you differentiate 4x squared with respect to y, that's 0. Differentiating 3xy squared, we carry down the power and subtract 1 from the power, so that's 6xy. And then we're differentiating 7x, we get 0. Differentiating 3y, we get plus 3. So that is fy. Okay, we're going to need fyy anyway, so let's find fyy. Fyy means we're differentiating 6xy with respect to y. So this we're going to get 6x. All right, nice. All right, let's also find fyx. Not fyx, fxy. Let's find fxy. Finding fxy means we're differentiating this right here with respect to y. We just get 6y. When you differentiate 8x with respect to y, you get 0. All right, and then it's 3y squared is 6y. Now let's find fxx. So to find fxx, we're differentiating with respect to x, and that just leaves 8. All right, good. So now we need to prove this. Remember, this is what we're trying to prove. This statement right here. This is what we're trying to prove. So first thing I'm going to do is start out with my left-hand side. My left-hand side is equal to 6fy minus 10. So if I have 6fy minus 10 on my left-hand side, let's go ahead and work that out. 6fy, this is fy. 6 times fy is going to be 6 times 6xy, which is 36xy. And then 6 times 3 is 18. Then I subtract 10. So what do I get? I get 36xy plus 8. Nice and easy. So that's what I get, 36xy plus 8. All right, now that I get that, let's go ahead now, moving right along. I now need to show that my right hand side is going to be the same. So my right hand side is going to be equal to, my right hand side is fyy times fxy. Fyy is 6x, and so it is 6x, which is fyy, multiplied by, that is fxy. Fxy is 6y plus fxx, and fxx is 8, so plus 8. All right, now 6x times 6y is 36xy. So this is 36xy plus 8. So I get 36xy plus 8. Nice. Now look at it. These two are the same, so it's proven. All right. Those two are the same, so it's proven. That's how you do that. Nice. Soft. So we justified this. Nice and easy. Moving right along. This question goes to ask us, use De Moivre's theorem to prove that sine 5x is equal to 16 sine to the 5th x minus 20 x cubed plus 5 sine x. So De Moivre's theorem states that, just writing down the theorem, cos theta plus I sine theta. I know that doesn't look like a plus too much, but oh well. Cos theta plus I sine theta raised to the nth power. De Moivre's theorem tells us that this is equal to cos n theta plus I sine n theta. So this is a theorem that we're going to use in order to solve this easy question. Cos theta plus I sine theta to the n is equal to cos n theta plus I sine n theta. So in this case, we're going to let n be equal to 5. If you can give n the value of 5, what you're going to get is cos theta. Well, instead of calling it theta, we're going to use x as well. So what you're going to get is cos x plus I sine x, cos x plus I sine x raised to the 5th power. All of this is now going to be equal to, remember, n is now 5. So since n is now 5, it's going to be equal to cos 5x plus I sine 5x. Yeah, man, that's what we're going to get. You're going to get cos 5x plus I sine 5x. That's what we're going to get. Nice. Now, the part that we really want to show is, we want to show that this 5x, this sine 5x right here, this is the imaginary part. We need to show that the imaginary part of 5x is equal to this expression over here. So in order to do this, we're going to need to expand the left-hand side. So let's go ahead and expand the left-hand side. So the left-hand side, to expand it, we're going to be using, but remember, Pascal triangle, to the 5th, it's the first one to the 5th, then to the 4th, then to the 3rd, then to the 2nd, and going down. So this is how we expand to the 5th power again. It's going to be the cosine of 5x. So cos to the 5th power of x plus, then it's going to be 5 times cos to the 4th power of x, and then it is multiplied by I sine x. Yeah, man, you have to remember this, man. Plus times I sine x plus, then it's going to be 10, 1, 5, 10. Then you go down again in power of cos. It's now cos cube. So it's now cos cube x times I sine x square I sine x square plus it is now 10 cos square of x multiplied by I sine x cube plus, then it's going to be 10. So we go 1, 5, 10, 10. So going on back to 5 now. Then it is 5 cos x times I sine x to the 4. And then it is plus I sine x to the 5. I know this is a very big expansion to do. It's very huge. And all of this, remember, all of this right there is equal to cos 5x. All of this is equal to cos 5x plus I sine 5x. Nice. Now this is where you're going to have to know powers of I. You have to know powers of I. You have to know powers of I. So let's get into powers of I. Getting into powers of I right here. Let's get into powers of I. Now, we're trying to prove this I sine 5x, so we need to equate the imaginary part. Now, this is going to be imaginary because we have I sine x right here. Now, I square is minus 1, so that's not imaginary. This part will be imaginary, and this part will be imaginary. So by equating the imaginary parts, we can finally find what sine x is. So let's write that down. Equating imaginary parts. Equating imaginary parts. What we're going to be getting now is that this part right here, sine 5x, is equal to 5 cos to the 4x times I times sine x, because we can ignore the I now because we're dropping off the I, we're equating the imaginary parts. So now sine 5x is equal to 5 cosine to the 4 of x times sine x plus, no, this part where I cube is minus I. So this is going to become minus 10 times cos square sine cube. So it's 10 times cos square x times sine cube x. Nice and easy so far. Then it's going to be this right here, which will have sine 5x. When we have sine 5x, wait, sine x to the 5th rather, sine x to the 5th. So this is plus sine x to the 5th. So sine 5x. Nice. So that is what sine 5x equal to. Now, if you look at the question, you observe that the question had nothing with cosine in it. And so we need nothing with cosine of that sort. So to get rid of cosine, we're going to need to have to substitute for cos something with sine. So let's go ahead and do some substitution. Now, cos to the 4th power is cos square square, but cos square is 1 minus sine square. So we're going to rewrite this as 5 times cos square is cos square is 1 minus sine square. So we can rewrite cos to the 4 as 1 minus sine square x. That is for cos square. And this is being squared. And then that is multiplied by sine x. That's multiplied by sine x. Then we'll have plus. When you change up the order, plus the sine to the 5th. Remember, addition is commutative and associative, so it doesn't matter which one I add first. Plus, then right here now, I'm going to change the cos square to 1 minus sine square, so it will become plus 10 times cos square is 1 minus sine square. So it's 10 times 1 minus sine square x times sine cube x. We're almost finished, man. We're almost. 2 more lines. Nice. So now to expand out 1 minus sine square, that's going to be first term square minus twice the product of the 2 plus second term square. So let's do that. All right. So what we're going to get is sine 5x. So sine 5x is equal to 5 times first term square. 1 square is 1 minus twice the product of the 2, which become minus 2 sine to the 4th of x plus the second term square and the second term square. Let me go again. First term square is 1 minus twice the product of the 2, so it will be, this shouldn't be 4, this should be 2 plus the second term square. Now sine square will give us now sine to the 4 of x. Right. So we get that when we expand the square. And remember, this is now being multiplied by sine x. It's now being multiplied by sine x. We can just put the sine x here. Plus, remember we were adding sine to the 5. We're adding sine to the 5 of x. Plus, we were adding 10 times something. We were adding 10 times this. So we can expand this out to get sine cube times 1 and sine cube times sine square. So it's going to be 10 times sine cube minus sine to the 5th. So this is plus 10 times. Oh, how did I have plus right here? Oh, this was minus. This A should have been minus. Why did I change the sign? That should be minus. That should have been a minus here. And so it should be a minus around here. So it's minus 10 times. Minus 10 times. And we said 1 times sine cube is sine cube. It's minus 10 times sine cube of x. And then we said sine square times sine cube. So it becomes minus sine to the 5th of x. Nice and easy so far. Now that we have this so far, all we need to do now is simplify this expression. So let's simplify it. Simplifying this expression, we're going to get that sine 5x is equal to 5 times 1 times sine x is 5 sine x. That part becomes 5 sine x. Then 5 times minus 2 is minus 10 times x is minus 10 sine cube x. Becomes minus 10 sine cube x. Then we have 5 times sine to the 4 times sine x is plus 5 sine to the 5th plus 5 sine to the 5th of x. And then you have plus sine to the 5th That's plus sine to the 5th of x. Then you have minus 10 times this becomes minus 10 sine cube x we have minus 10 times minus sine to the 5th. That's just plus 10 sine to the 5th plus 10 sine to the 5th of x. All right, and so what we're going to get is sine 5x is going to be equal to sine 5x is going to be equal to sine to the 5th plus 5 sine to the 5th plus another sine to the 5th. That is 16 sine to the 5th. So we get 16 sine 5 to the 5th. And then you have minus 10 sine cube and minus 10 sine cube is minus 20 sine cube x. Then when you have plus what left? Just the 5 sine x. So see, there will prove this question. Nice and easy, soft. There was nothing really to it at all. Nothing at all. Nice. That completes this question. All right, now this question says, write the complex number z, which is equal to minus 1 plus root 3i to the 7th power in the form re to the I theta. So write it in the form re to the I times theta. So let's go ahead and do that. So first, I want to call this piece inside here p. I'm going to call this p. I'm going to call it p to the 7th power. All right, just for now. So the part that is p, I'm saying p is equal to minus 1 plus root 3i. So since p is equal to minus 1 plus root 3i, I first need to think about which quadrant that is in. Minus 1 for x is over here, plus root 3, so it's in the second quadrant. And so the angle is going to be pi plus. This is the angle between the positive real axis and the, all right, so that's the angle that we're going to want. So we needed to just draw the Argand diagram to see what's happening. And so the modulus of p is going to be equal to minus 1 square plus root 3 square. Root 3 square is just 3, all square rooted. So when I work that out, I'm getting a square root of 4, and the square root of 4 is 2. Now that I get that, now I need to find my angle, which is my argument. And the argument, I'm going to call it theta 1. So my argument theta 1 is going to be equal to tan inverse, or pi plus tan inverse of y over x. So it's pi plus tan inverse of, it's pi plus tan inverse of root 3 over minus 1 is minus root 3. And so you put that in your calculator to find out what's tan inverse of minus root 3. Tan inverse of minus root 3. According to my calculator, I'm getting minus pi by 3. So I get minus pi by 3. And so I really have pi minus pi by 3. And so that's going to be 2 pi by 3. Pi minus pi by 3 is 2 pi by 3. 2 pi by 3. Nice and easy. Now that's theta 1. That's theta 1. But what we need is theta. So the modulus of z now is going to be equal to, remember it's being raised to the 7th power. So it's going to be 2 to the 7th power. and 2 to the 7th power is, okay, put in my calculator, 2 to the 7th, that's 128. That's the modulus of z. Really sad I didn't remember that. All right, and then now we need an argument of z, which is theta, and the argument of z is going to be 7 times 2 pi over 3. So it's 7 times 2 pi over 3. 7 times 2 is 14 pi over 3. 14 pi by 3. That's what I get for theta, 14 pi divided by 3. Nice. This is what I get. All right, so this is what I get. So moving right along. It says now, hence prove that this is equal to this. Hence, oh, I didn't even finish this part. We didn't finish, so we needed to say then that the complex number z can be written as, it's said to write it in the form r e to the I times theta. So it's 128 e to the 14 pi by 3, 14 pi by 3i. All right, because I saw the hence, made me realize that we didn't finish it. So now we finish it, we can continue. And it says, prove that this now. So since it says hence, it means we have to use what we did around there. So the hence, remember we said that z is now 128. Z is now 128 e to the 14 pi by 3 times I. Since it says hence, this is what we're going to use. I don't like to work in exponential, so I convert it to polar form. In polar form, this would be 128 times cos 14 pi by 3 cos 14 pi over 3 cos 14 pi over 3 plus I sine 14 pi over 3. Plus I sine 14 pi over 3. Nice and easy, soft. So now that we have this now we can continue and work out z. You put in a calculator what is cos of 14 pi, you're going to get 128 times the cos 14 pi divided by 3, and you find the cos of that. I'm getting negative a half. I'm getting minus a half right here. Minus a half plus, you find out what is now the sine of 14 pi by 3. 14 pi divided by 3. The sine of that is root 3 over 2. So I get root 3 over 2 times I. Now look what I'm going to do right here now. Instead of writing 128, I'm going to break up 128 as 64 times, 128 can be written as 64 times 2, and then the 2 is going to be multiplied by minus half plus root 2 over 2 times I. Root 2 over 2 times I. And so now we can finish off this question very easy. This question get too easy now. So what we get is 2 times minus 1 is 2 times minus half. That's just minus 1. So we get 64 times minus 1. And then 2 times root 2 over 2. The 2's cancel, so you just get, oh, this is root 3 over 2. Why did I write root 2 over 2? This should have been root 3 over 2. root 3 over 2. My apologies there. Check it in a calculator, you get 0.866, which is root 3 over 2, root 3 over 2. And then you finally work this out now. Then you get this 2 cancels this 2, you get plus root 3 times I. Nice and easy, solved. This concludes this question. Proven. Nice and easy. So all of this is now proven. Nice. Now we reach around here. Question 2, it says, so question 1 pretty much dealt with differentiation and complex numbers. This is going to deal with more integration. So it says, let fn of x be equal to the integral of ln x to the n. Show that fn x is equal to x times ln x to the n minus n times fn minus 1 of x. All right, so we're supposed to show this. Now let's do this question now. Show that fn x is this. Now, to do this question, very easy to do this question. So we're going to have to use integration by parts. But first, we're going to have to rewrite fn x. We're going to have to rewrite fn x as the integral of, instead of saying ln x to the n, we're going to write ln x to the n times 1. So it's ln x to the n multiplied by 1 dx. And you might say, what's the importance of 1? The importance of multiplying it by 1, this will allow us to utilize by parts. And by parts tell us that the integral of u dv is equal to what? It's equal to uv minus v du. Yes, this, we have to remember that. We have to. So applying this, we need to call u ln x to the n. So u is equal to ln x raised to the nth power. And if this is u, then you need to find du. What's going to be du? Du is going to be, you carry down the power of n, you subtract 1 from the power to get ln x to the n minus 1. Then you multiply it by the derivative of what's inside the bracket, and the derivative of ln x is 1 over x. So we can just put all of this over x. We're going to then call dv1, and if dv is equal to 1, then v is going to be equal to the integral of 1, and the integral of 1 is x. Nice. Now, once we have that now, what we're going to get is fnx is equal to, using the by parts formula, remember we said in the by parts formula it's u times v, so it's going to be x times ln x to the n, it's u times v minus the integral of v du. Now v times du, if you look at it, you're going to get v times du is going to be x times all of this would become nx ln x to the n minus 1 over x. Now, as you can realize right here, the x's are going to cancel, and you can then factor out the n. You can factor out this n. Let's factor out the n and put the n out here. And so now what you're left back with now is the integral of ln x to the n minus 1. But the integral of ln x to the n is fn. So this is just fn minus 1. So this works out to be x ln x. This works out to be x ln x x ln x to the n minus n times fn minus 1. Fn minus 1 of x. Nice and easy, soft. That's how we do this question. Very easy. All right, nice. All right, so let's go ahead now. And it says, hence or otherwise show that f32 minus f31 is this. Now to do this proof, let's write down, it says hence, meaning we're going to utilize this knowledge. We're going to use the fact that fnx, we're going to use the fact that fnx is equal to x ln x, it's x ln x to the n minus n times fn minus 1. So we're going to use this knowledge. That's what hence mean. Hence mean use this knowledge that you just showed around there to prove this question above. Hence. Otherwise mean you can do something else. But we're going to go hence. All right, so we're using this knowledge around here. Why did it skip do that? All right, so let's use that knowledge that we have. Using that knowledge that we have, we're going to plug in n as 3. N is now 3, so plugging in n as 3, you're going to get that f3 of x is equal to, replacing n with 3, you're going to get that it is equal to x ln x raised to the third power, because you're substituting n as 3, minus n is now 3, putting n as 3, you get f2x, that is f2 of x. Right. Now that that is what we get, we can continue, and so f3x is equal to x ln x cube, it's x ln x, x ln x cube minus 3 times f2x, but f2x is now, to find f2x, we're going to have to go back to this formula again and put n as 2. Putting n as 2, we're going to get x ln x square, x ln x square, minus, putting in n as 2, you get 2 times f, then n as 2 here is 2 minus 1 is 1, so it's 2 f1x. Nice. So this is what we get. You may proceed and go further to expand, and you're going to get x ln x cube. You're going to get x ln x cube. Then you expand in the minus 3 here, you're getting minus 3x ln x square minus 3x ln x square, and then minus 3 times minus 2 give plus, that become plus 6 f1x. So I know the question you're going to ask. We're going to need to find f1x again, sir? Yes, we're going to need to find f1x. Finding f1x, we're just going to replace n with 1. So finally, or penultimately, we're going to get that ln x cube minus 3x times ln x square plus 6f1 is going to be 6 times f1x. Now is we're putting in n as 1. Putting in n as 1, we're getting, putting in n as 1 right here. f1x is x ln x to the 1. So it's now x times ln x to the 1. We don't need to do that. minus n as 1, so that's just 1, times f naught. So 1 minus 1 is f naught, so it's minus f naught. But now you're going to ask, sir, how you find f naught? Because if I put in n as 0, you're going to have 0 minus 1. Now, once you reach f naught, go back to the original function. If you were to put n as 0, what would you get? ln x to the 0 is 1. The integral of 1 is x. And so all you have to do now is replace f naught with just x. So f naught is equal to x. Let's do that one more time. To find f naught, you'd put n as 0. If you change n as 0, you get ln x to the 0. Anything to the 0 is 1. And so the integral of 1 is x. So this is just x. So now we have f3x. This is the formula for f3x. Now that we have the formula for f3x, we can find f32 and subtract f31. So now f32 minus f31 is going to be equal to f32 minus f31 is equal to, let's make it have some more space. We're going to go out a little bit. f32 minus f31. f32 mean we're plugging in x as 2 now. So it's going to be 2 ln x, and it is ln x being cubed, 2 ln x cubed minus, put x as 2, you get 6 ln x squared. Then you put x as 2 again, you get plus 6 times, you put x as 2 here, 6 times 2 is 12, so this is really plus 12 ln x. So erase that and put plus 12 ln x. Then you put x as 2 here, you get 6 times 2, that's minus 12. You close up that bracket and then you subtract. What you're going to subtract is f3(1). So you put x as 1 is in here. When you put x as 1, ln 1 is 0. So you're just going to get 0 minus 0 plus, putting in x as 1 here, you're going to get ln 0. ln 1 is 0. Put x as 1 here, you get minus 6. So that part becomes minus 6 in here. So this part becomes minus 6. And so now you may proceed and go ahead. And you're going to have all of this, but minus 12 minus minus 6 is just minus 6. So all of this works out to just be 2 ln x cubed minus 6 ln x squared minus 6 ln x squared plus 12 ln x minus 6. So proving this question nice and easy, soft, a capital T. Nice. This is proven. All right, moving right along. Moving right along, it says, by expressing y squared plus 2y plus y to the 4 plus 2y squared plus 1 in partial fraction, show that this is true. So let's go ahead and do this question by expressing it in partial fraction. So I'm going to call this I. Don't like to write out this whole heap, so I'm going to call it I. Calling this I am getting that I can write that I is equal to y to the 4 plus 2y squared plus 1. I can then be equal to ay plus b over all of this right here is really y to the 4. All of this can be broken down. What I'm saying is that denominator, y to the 4 plus 2y squared plus 1, this denominator right here, if you really examine it, you're going to see that this denominator is really just y squared plus 1 being squared. That's all it is, y squared plus 1 being squared. So when you're separating it as a partial fraction, you can rewrite it as ay plus b over y squared plus 1 plus cy plus d over y squared plus 1 all squared. That's how you separate it in partial fraction. Nice and easy. So there's no issue with this question. This is how you separate it in partial fraction. Nice. All right, so let's go ahead and continue. So continuing this now, all we need to do is express this as one fraction first by finding the common LCM, which we know is y squared plus 1 all squared. And so this into this just leaves y squared plus 1, so it's going to be ay plus b and this is multiplied by y squared plus 1 plus y squared plus 1 all squared into y squared plus 1 all squared is just cy plus d. That's what we have. Nice. So let's go ahead now. Keep on working, keep on working. So you have to have ay plus b times y squared plus 1. Ay times y squared is ay cubed. Then ay times 1 is ay. And then b times y squared is by squared. And b times 1 is b. Plus cy plus d. Nice and easy, soft. And then now you have right here, you have y squared plus 2y plus 1. Remember, that's what I is, y squared plus 2y plus 1. And that's by equating the numerators. Let me move over this equal sign. And their denominators are the same, so we don't even need to look. We can just ignore the denominator now. We can just ignore the denominator because the denominator is both the same. It's both y squared plus 1 all squared. So when the denominators are the same, we're equating the numerators. So that's what we're going to do now. So right here, we're equating numerators. So equating the numerators, what do we notice? We notice there's no y cubed over here. And so clearly, a is equal to 0. If a is equal to 0, then what do we know? If a is equal to 0, then equate the y terms, the y squared terms, equating the y squared terms, we're going to get b equal 1, clearly. Then equating the y terms, we're going to see that 2y is equal to ay plus cy. And if 2y is equal to ay plus cy, then if we divide through by y, we get 2 is equal to a plus c. But what do we know? We know that a equals 0. So that's telling us that C equal 2. And then if C equal to, equating our constants, we have B plus D is equal to 1. Equating constants, 1 is equal to B plus D. And since 1 is equal to B plus D, but B is 1, then D must be 0. So D is equal to 0. Now that D is equal to 0, we're good. So AY plus B is going to be AY plus B. A is 0. So 0 times Y is 0 plus B. B is 1. So it's now 1 over Y squared plus 1 plus CY. C times Y is 2 times Y, which is 2Y plus D. D is 0, so it's just 2Y over Y squared plus 1 all squared. So there you have it, nice and easy, soft. So we've shown that this partial fraction is true. That's what we get when we separate it in partial fraction. So proven, soft, giving away 7 marks. All right. Now, hence, calculate the integral of this. Now, when it says hence, it means you're going to use the partial fraction to do it. So I like to call this integral I. So I'm going to say I is now equal to, we're using what we just found. I is now the integral of 1 over Y squared plus 1 dy plus integral of, what was the other piece we got? 2y over Y squared plus 1 all squared. That was the other piece we had gotten, dy. So if this is what we're going to be evaluating, then we can proceed. We may proceed to work this out now. We may proceed, and the integral of 1 over Y squared plus 1, that's just tan inverse of Y. You have to know those by heart. This is just tan inverse of Y. That's integration by recognition. Plus, now this part now, to do the integral of this part, what you're going to have to do is do some substitution. I want you to call U Y squared plus 1. If U is equal to Y squared plus 1, then what is du? Du is going to be equal to 2y dy. So what does that mean for us? That means that this piece right here is going to become the integral of, use the u substitution, it becomes 1 over u squared du. And so what we're getting is that I is equal to tan inverse of y plus, now when you're integrating 1 over u squared, that is u to the minus 1. And so you can write it as minus 1 over u. That's what you get when you integrate 1 over u squared. Then remember, when you integrate, you put plus c. But then what was u? U was y squared plus 1. This is just tan inverse of y. Tan inverse of y minus 1 over u, which is minus 1 over y squared plus 1, plus some constant c. Nice and easy, soft. Nice. That's how we do it. Nice and easy. Moving right along. Oh, we finish. So that takes care of question 2, module 2. Continuing. Finally. All right, so as we said, module 2. Determine the coefficient of x cubed in this binomial expansion. So Determine the coefficient of x cubed. That's easy. Nice. So I like to call it the term in x cubed. So for the term in x cubed, it's going to be NCR, n is 5. It's 5 choose 2 of 3x cube times 2 square. And what is 5 choose 2? 5 choose 2 is 10 times 3 cube times 2 square. When you work out all of this, you will get 1080 x cubed. But the question asks you for the coefficient. And so you can't just leave it at that. You need to just tell them so the coefficient of the x cubed term, coefficient of x cubed is 1080. Nice and easy, soft. Next part of the question says, show that the binomial expansion of 1 plus x to the quarter plus 1 minus x to the quarter up to the x squared term is 2 minus 3 over 16x squared. So we need to use binomial expansion to do this up to the x squared term. Now, the binomial expansion, just for those who don't remember, it goes by 1 plus x to the n and 1 plus x to the n. As we all know, this is equal to 1 plus nx plus n times n minus 1, n times n minus 1 times x squared over 2 factorial over 2. That's it. All right. So we need to show this binomial expansion up to the x squared term. So let's go ahead and do that. So what we're going to get is 1 plus x raised to the quarter plus 1 minus x raised to the quarter. This is going to be equal to, we're going to be utilizing the formula here. This is equal to the 1 plus x to the quarter is going to be 1 plus nx. N is a quarter, x is x. So it's going to be a quarter x plus n times n minus 1 is going to be a quarter times n minus 1. 1 minus a quarter is minus 3 over 4 times x squared. And this is being divided by 2. So this part is for 1 plus x to the quarter. Then we're going to need plus this part now, which is 1 minus x to the quarter. So that part is going to be plus 1 plus nx. In this case, n is a quarter, but x is minus x. So it's going to be 1 plus a quarter times minus x. So it's a quarter times minus x plus n times n minus 1 is now plus a quarter times minus 3/4 over 2 times minus x squared. But minus x squared is just x squared. That's just x squared. So this part will simplify to be 1 plus a quarter x then right here we have a quarter times minus 3 over 4 That is going to be a quarter times minus 3 over 4 divided by 2. That's minus 3 over 32 minus 3 over 32 x squared. Then we're going to get plus 1 minus a quarter x. Then we're going to get minus 3 over 32 x squared. Now, as you can see, the quarter x and the quarter x cancel. And so what we're left back with is a 1 plus 1. 1 plus 1 is 2. So we get 2. Then minus 3 over 32. Minus 3 over 32 is minus 6 over 32, which is minus 3 over 16. So we're showing it nice and easy, soft. Next part. Hence, by putting x as 1 over 16, compute an approximation of the quart root of 17 plus the quart root of 15 correct to 4 decimal place. It says put in x as what? 1 over 16. Put in x as 1 over 16. So we're going to use x as 1 over 16 here. So it's going to be 1 plus 1 over 16 to the 1 over 4 plus 1 minus 1 over 16 to the 1 over 4. That's going to be equal to, we're substituting x as 1 over 16 in this formula. So we're going to get 2 minus 3 over 16. 2 minus 3 over 16 times x, and x squared in this case is 1 over 60 squared. And so when you do that, what you're going to get is, expanding that right hand side, what we're going to get is 2 minus 3 over 16 times 1 over 16 squared. On the right hand side, I'm getting 1.999, and it says the 4 decimal place, so I'll keep it at 9 here. 1.99, oh, that's 1.993. 1.993. And then looking at the left hand side now, 1 plus 1 over 16, that is 17 over 16. And when it says to the 1 over 4, that's just the quart root. This is the quart root of 17 over 16 plus, this part is now just going to be the quart root of 15 over 16. Now, we may proceed now and to separate this. And what you can do is, instead of having the quart root of 17 over 16, break it up as the quart root of 17 over the quart root of 16. That's how I want you to look at it. The quart root of 17 over the quart root of 16. Plus, this part I want you to separate it as the quart root of 15 over the quart root of 16. And that's equal to 1.9993. Now the quart root of 16 is going to be, the quart root of 16, you put that in your calculator, quart root Quart root just means square root in 16 twice. So that's 2. So this right here is really 2. So all we need to do is multiply through by 2 to get the quart root of 17 plus the quart root of 15. That's going to be equal to 2 times this. 2 times that is 1.9993 times 2, 3.9986. That gives me 3.9986. That's the final answer. Nice and easy, soft. Moving right along. This question says, a function h of x is defined on the interval 0, 1. It says, show that h of x has a root on the interval 0, 1. To show that h of x has a root on the interval, we need to use IMVT, intermediate value theorem. So first, we're going to plug in h of 0. Plugging in h of 0, you get 0 cubed plus 0 minus 1. So h of 0 is minus 1, which is less than 0. And then you need to plug in 1. When you plug in h as 1, what you're going to get is 1 cubed is 1 plus 1 is 2. 2 minus 1 is 1. And that's greater than 0. Now, if you're to draw a sketch of this function, then when x equals 0, y is negative 1. And when x equals 1, y is also 1. So if you're to draw a curve, it looks something like this, don't it? And so there must be a root between 0 and 1. Yeah, man. And so by IVT, or you can say since f of x, oh, this is not f, this is h. Since h of x is continuous on the interval 0, 1, and h of 0 is less than 0, and h of 1 is greater than 0, then by IMVT, by intermediate value theorem, there exists a root on the interval 0, 1. Nice and easy. So that takes care of this question. It says, use the iteration xn plus 1 is equal to 1 over xn squared plus 1 to estimate the root of h of x. So let's do this question. So to find the second approximated root x2, it's going to be 1 over xn squared, which is 0.7, and 0.7 is squared plus 1. So you go ahead and you work that out. 0.7 squared plus 1, and 1 divided by that, you get 0.67. 0.67. Nice and easy, soft. Now, you need to then find out x3. What is x3? x3 is now 1 over, putting in x2 now, x3 is 1 over 0.67 squared plus 1. And when you put that in your calculator, you're going to get 0.67 squared plus 1. 1 divided by such answer, I get 0.69. So I'm getting, let me check that again. (0.67), I square it, add 1 divided by the answer is 0.69. Okay, I get 0.69. So let's repeat this again now. See what we get now for x4. We're trying to find an approximated root. So it's 1 over 0.69. We square that and add 1 to it. Square plus 1. And you work that out. What you're going to get is 0.69 squared plus 1. 1 divided by such answer. I get 0.68. So now I get 0.68. Let's try it again now. Doing it one more time. x5 would be equal to 1 over 0.68 square plus 1. And what you're getting is 0.68 squared plus 1. 1 divided by such answer, you're getting 0.68. Since 0.68 is repeated, we can assume that the approximated root is 0.68. So once you get the same answer twice, you can stop. So hence an approximated root is 0.68. Nice. We're finished right there. That's an approximated root. All right, moving right along. It says, use a Newton-Raphson method with initial estimate x1 being 5.5 to approximate the root of g of x, where g of x is sine 3x in the interval 5, 6. Using Newton-Raphson formula, you have to remember Newton-Raphson formula tells us that xn plus 1 is equal to xn minus f of xn over f prime xn. All right, let me not use f. Given that this function is using g, it's probably a smarter idea to use g. So it's xn minus g of xn over g prime xn. Nice and easy, soft. So now let's go ahead and proceed. Let's go ahead and proceed to do this question. So going ahead and proceed to do this question, we need to find out what is, since we're using 5.5 as an estimate, let's go ahead and find out what is g of 5.5. G of 5.5 will be equal to substituting x as 5.5. So you have sine of 3 times 5.5, and you're getting 3 times 5.5 is 16.5. The sine of 16.5 is negative. This is negative 0.711. It's negative 0.7118. And so if this is now g of 5.5, we need to find g prime of x now. G prime of x will be equal to, you differentiate this function with respect to x. When you differentiate sine, you get cos. So you get 3 cos 3x. And so we need to find out what is g prime of 5.5. So you plug this in your calculator now and you get 3 times the cosine of 3x, which is, let's put that in a calculator. Let's work that out. The cosine of 16.5 times 3 is minus 2.11. So you get minus 2.11. And so what does that mean for us? That means that the approximated root, let's call it x2, is equal to x1, which is 5.5, minus, this is using the formula g of xn, which is minus negative 0.7118, and all of this is being divided by g prime of xn. G prime of xn, so it's divided by negative 2.11. Doing this division, so what we're getting is x2 is equal to, doing this division, x2 is equal to minus 0.7118 divided by negative 2.11. I get 0.337, and so 5.5 minus that, I get 5.16. So the approximated root is 5.16. Nice and easy, soft. 5.16 is the approximated root. Nice. Nice and easy, we get 5.16. Moving right along. It says a function is defined as g of x is equal to x sine x over 2. Obtain the Maclaurin series expansion for g up to the x to the 4th term. So to obtain a Maclaurin series expansion for g in terms of x to the 4, that means we're going to have to differentiate 4 times. Oh my gosh, 4 times. But no worries, we're having fun. So we start by writing down g of x, and g of x is equal to x sine x over 2. That's g of x, x sine x over 2. And so that implies that when you plug in x as 0, you're going to get that g of 0 is equal to 0. Let's go ahead and find g prime of x now. G prime of x is going to be equal to, we're going to have to use product rule to differentiate this. Keep the first, when you differentiate the second, when you differentiate sine x over 2, you get cos x over 2 times a half. So I can write it as x over 2, cos x over 2, plus, you keep the second, times the derivative of the first, so you get plus sine x over 2 times the derivative of x, which is 1. So that's g prime of x. If this is g prime of x, then that is telling us that g prime of 0 is equal to, when x is equal to 0, you're going to get, well, if x is equal to 0, we still get 0. No matter what, g prime of 0 is 0, sine of 0 is 0. All right, so let's keep working because we're getting 0 so far. Now g double prime of x. For g double prime of x, what we're going to get is keep the first. So now we're going to keep our x over 2. Keep the first, x over 2, times the derivative of the second. The derivative of the second is when you differentiate cos x over 2, you get sine x over 2. When you differentiate cos, you get minus sine, that is, and then you multiply it by a half. A half times x over 2, I can just put x over 4. Plus, keep the second, which is x over 2, times the derivative of x over 2. The derivative of x over 2 is a half. So I'll get a half cos x over 2 plus, when I differentiate sine x over 2, I get minus, when you differentiate sine, you get cos. So it becomes plus, not minus. Plus cos x over 2 times half, which is plus a half cos x over 2. Nice and easy, soft. That is what we're getting. And so if you're to go ahead now and to substitute as 0, let's substitute 0 somewhere. If you plug in 0, you get 0 minus 0 plus. You plug in 0 here, the cos of 0. The cos of 0 is 1. And so you get a half plus a half, which is 1. And so what we get is g double prime of 0 is equal to 1. Nice and easy, soft. All right, nice. Now, right here now, once you have g double prime of 0, which is equal to 1, you may go ahead and you proceed and to find the third derivative, g triple prime. So g triple prime of 0, before we can even find g triple prime of 0, we need to find g triple prime of x. So g triple prime of x is equal to, we're going to have to differentiate this right here. Instead of writing the minus in front of the sign, you can put the minus in front of the x over 4. All right, instead of having the minus sign right there, so put the minus sign right here, so that looks a little better. So differentiating this part now, it's going to be keep the first, which is minus x over 4, times the differential of the second. When you differentiate sine, you get cos, then you multiply it by half. When you times x over 4 by half, you get x over 8. So it's really x over 8 times the cos of x over 2 plus keep the second times the derivative of the first. The derivative of x over 4 is minus a quarter, so this becomes minus a quarter sine x over 2 then you're going to differentiate this now, which is a half cos x over 2. When you differentiate a half cos x over 2, what you're getting is, when you differentiate cos, you get minus sine. When you differentiate cos, you get minus sine. So this then becomes minus a quarter sine x over 2 minus a quarter sine x over 2. Then we're going to have to differentiate this now. When you differentiate, why didn't I just do this? A half cos x over 2 plus a half cos x over 2 is just cos x over 2. Since you just have cos x over 2, you can just change this to minus a half sine x over 2. And what does this mean? This means that we're going to get that g triple prime of 0 is 0. That's what we're going to get. G triple prime of 0 is 0. Nice. All right, so continuing right along now, we have g prime 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 of x is going to be equal to, you keep the first times the derivative of the second. When you differentiate cos, When you differentiate cos, you're going to get minus sine. And so minus and minus will become plus. This will just become x over 16 sine x over 2. Plus you keep the second times the derivative of the first. When you keep the second, it's cos x over 2 times the derivative of the first. That's minus 1 over 8 cos x over 2 nice. And then what we have now is when you differentiate sine x over 2, you're going to get minus a quarter cos x over 2 all right. And then finally, when you differentiate right here, we just need a little more space to differentiate. Oh, when you differentiate a quarter sine x over 2, you actually get minus times a half. Again, so it becomes minus 1 over 8. Then you need to differentiate a half sine x over 2, and you're going to get minus a half times a half is a quarter. Just because we don't have much space, all right, minus 0.25 sine. Differentiate sine, you get cos, so minus 0.25 cos x over 2. Cos x over 2. So what does that mean for us? That means that, going around here to complete it, that means that g prime 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 plus 0 is equal to, let's finish it off, g prime 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 of 0 is equal to, plugging in 0, we get 0. Plugging in 0 here, we have the cos of 0. This becomes 1, so you have minus 1 over 8, minus 1 over 8, minus a quarter. That works out to be minus 1 over 8, minus 1 over 8, minus a quarter. And this will give us minus 1 over 8, minus 1 over 8, minus a quarter. That will give us minus a half. Okay, now we're ready to put it in an approximated form. So using Maclaurin expansion, we know that g of x is going to be equal to g of 0 plus g prime of 0 times x plus g double prime of 0 times x squared over 2 factorial, and the formula continues. So let's go ahead now and approximate g of x. So using the approximation, g of x is equal to, what was g of 0? We found g of 0 to be 0, g prime of 0 to be 0, g double prime of 0 to be 1. So this is going to be equal to g of 0, which is 0, plus g prime of 0, which is 0, plus g double prime, which we found to be 1. So that worked out to be 2 squared, x squared, over 2 factorial, which is 2, plus g triple prime, which is going to be 0, plus g prime 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 prime, quadruple prime, which we found to be minus a half. So that will just be, instead of writing plus, let's put minus. This will just be minus 1 over 2 minus 1 over 2x squared. So it's minus 1 over 2x squared. And this is, of course, being divided by 4 factorial. And so in reality, g of x works out to be a half x squared and then minus a quarter over 4 factorial is minus a quarter minus a half divided by 4 factorial is minus 1 over 48. This should be x to the 4 minus 1 over 48 x to the 4. That is g of x. Nice and easy, soft. All right. So that's our approximation of g of x. A half x squared minus 1 over 48 x to the 4. Hence, estimate g of 2. G of 2. To estimate g of 2, we just put in x as 2. So g of 2 is going to be equal to a half. G of 2 is going to be equal to a half 2 squared minus 1 over 48 times 2 to the 4th power. This is using our approximated formula. So going right along, what we're going to get is g of 2 is equal to a half 2 squared minus 1 over 48 times 2 squared. That is 1.9166. So I'm getting 1.917. Probably I should round off to 3 significant figures. I write it as 1.92. 1.92. Looking at it now, 1.92. 1.92, looking at it, 1.92, where is it? Oh, so looking at this now, we're saying you could try x as 2 here. Sine of 1 times 2. If you try x as 2 here, you're getting sine of 2 over 2 is 1. Sine of 1 times 2, you're going to get 1.68. This approximated value is a little bit off. Oh no, it's not off. I did some error right here. This should have been to the 4th power because I was wondering why that was so far off. It should have been to the 4th power. And so in reality, this is not 1.92. It is actually 1.67. That's your approximation. Nice and easy, soft. A capital T. Now the next part B, says a series is given by 2 plus 3/4 plus 4 over 9 plus 5 over 16 plus blah, 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 blah. So I'm going to rewrite it as 2 over 1 so we can catch the pattern plus 3 over 4 plus 4 over 9 plus going all the way up to the nth term. If you look at the nth term, it's going to be n plus 1 over n squared. Yeah, man, that's the formula. So when n is 1, you get 1 plus 1, which is 2 over 1. When n is 2, it is 2 plus 1, 3 over 2 squared, which is 4. So that's how you find it. And so this can be expressed then as the sum using a dummy variable from k equal 1 to the nth term of k plus 1 over k squared. That's how you can write this. And they call it Sn. So Sn is k equal 1 to n of k plus 1 over k squared. Nice. All right, it says calculate S20 minus S18. S20 minus S18. Now, if you're going to find out what is S20 minus S18, there's something I want to show you, right? If you're working out Sn minus Sn minus 1, what you would get is just the last term, Tn. And so what that means is if you're working out Sn minus Sn minus 2, what you get is Tn plus Tn minus 1. This is what you get. What does that mean? If you're working out S20, you're working out S20 minus S18, it's going to be equal to the 19th term and the 20th term. So it's T20 plus T19. Right? So that's what you would get. Nice and easy, soft. If you don't follow what I'm saying right here, if this doesn't make any sense to you, what I want to say is the sum from 1 to 18 plus the 19 plus the 20th term, that must be a S20. Right? What I'm saying is the sum from 1 to 18, which is S18. Think about it this way. S18 plus S18 plus the 19th term plus the 20th term. When you add these three, you must get the sum from 1 to 20, right? So what I'm saying is if you subtract S18 from both sides, you get T19 plus T20. So what does that mean? This means that all we need to do is find T19 and T20. All right. So this is equal to term 19 plus term 20. And the 19th term is going to be n plus 1 over n squared. So it's 19 plus 1 is 20 over 19 squared plus n plus 1 is 21 over n squared, which is 20 squared. You add those and you're getting, so 20 over 19 squared plus 21 over 20 squared (20 divided by 19 squared) plus 21 divided by 20 squared, 0.1. So I get 0.1 0.108. That's what I'm getting. Nice and easy, soft. That's that. Now it says, given that the sum from 1 to infinity of 1 over n squared converges, show that Sn diverges. So to show that Sn diverges, there are 3 ways you can do this. Even though we're going to use this anyways, there are 3 ways you can do it. Let's start by using the divergence test. So using the divergence test, we just need to show that this k plus 1 over k squared, or we just need to show that rather n plus 1 over n squared, we need to show that this is not going to 0. If it is not going to 0 as n goes to infinity, then it diverges. So if it's not going to 0 as n goes to infinity, then it diverges. So this is what we need to show, that n plus 1 over n squared does not go to 0. How are we going to show that? We're going to show that by applying limits. So we're going to say that the limit as n goes to infinity of n plus 1 over n squared, this is going to be equal to the limit as n goes to infinity of, separate it as 2 fractions. It is now n over n squared plus the limit as n goes to infinity of, plus the limit as n goes to infinity of 1 over n squared. Now the part that says n over n squared, we can simplify this part to be 1 over n. We can simplify this to be 1 over n. Alright, so since you can simplify this to be 1 over n, right, then we can apply. But look what this said. It tells us that this converges. So if this converges, then they're telling us that the limit of 1 over n squared is L. So they're telling us that this limit is L, which is a finite value. They're telling us that this is L. This converges to a finite value L. So this limit is L. And the limit of this, as you apply infinity, 1 over infinity is 0, right? But this converges to L. So since the limit of this is L, then this does not go to 0. And so n plus 1 over n squared does not converge to 0. It don't converge to 0, it's converging to L. And so Sn diverges. This is using the divergence test, nice and easy. So, all right, it says use method of induction to prove this. You don't have to use induction. It could have been method of differences, but they want us to use induction. So for induction, we start by going for n equal 1. For n is equal to 1, and we're proving this by induction, it's going to be, proving this by induction, it's going to be the sum from R. Well, don't even need to write all of this long thing right here. For n equal 1, I'm just going to write left-hand side. Can't bother to write out this summation. For n equal 1, it's going to be 1 times 1 minus 1. N equal 1, it is 1 times 1 minus 1. And that's equal to 0. And the right-hand side is equal to plug it in R on the right hand side, n as 1, you get 1 times 1 square minus 1 over 3. So you get 1 times 1 minus 1 over 3, and that is still 0. And so n equal 1 is true. So therefore, n equal 1 is true. So now we need to look at when n is equal to k. When n is equal to k, what is going to happen? Let us find out. We're going to do some assumption. For n is equal to k, then this is going to become the summation. It's going to become the summation from r equal 1. It's going to become the summation from r equal 1. It's going to become the summation from r equal 1 to k of r into r minus 1. That's what that is going to be. The sum from 1 to k of r into r minus 1. And that is then equal to k, by replacing n with k. So it's k times k squared minus 1 being divided by 3. So it's k times k squared minus 1. And all of this is being divided by 3. Nice and easy. So that's what we have, and we're going to assume that this is true. We're going to assume n equal k is true. Since we're assuming this now, let's go ahead and work out the others. And so for n equal to k, for n equal to k plus 1, we are going to get the sum from r equal 1. We're going to get the sum from r equal 1 to k plus 1, because n is now k plus 1, of r into r minus 1. This is now going to be equal to the sum from 1 to k. It's now equal to the sum from r equal 1 to k. It's a sum from r equal 1 to k plus the k plus 1 term. Plus the k plus 1 term. K plus 1 terms. T stands for term. Let me write it out. K plus 1 term. All right, so let's go ahead and work this out. So what we're going to get now is, this is now the sum from r equal 1 to k plus 1 of r times r minus 1. And that's equal to the sum from 1 to k. We found that the sum from 1 to k, we said that it was k times k squared minus 1 over 3, plus the k plus 1 term is going to be, replace r with k plus 1. So the k plus 1 term will be k plus 1 times k. K plus 1 times k. Now what I'm going to do is, instead of writing just k times k plus 1, I'm going to put a 3 here and I divide it back by 3. So I didn't change anything to it. You might say, sir, why you do that? I did that so I can factor out what's in common of both of them. Because k squared minus 1, this can be written as k squared minus 1 is a difference of 2 squared. I can write it as k times k plus 1 times k minus 1 . This is all over 3 plus this part now is just 3k times k plus 1. This is 3k times k plus 1 over 3. So what I need to do now is I can factor out what's in common. What I'm going to factor out is k plus 1 over 3. So I'm going to factor out k plus 1 over 3. And I'm going to left back inside this bracket with, I'm going to be left back with k times k minus 1. I'm going to be left back with k times k minus 1 plus I'm going to be left back in here with just 3k. You might say, sir, why didn't you factor out k2? I didn't factor out k2 because remember, we're trying to prove something. All right? We need to factor out what we need to factor out. So what this is going to work out to be is k plus 1 over 3 into, this becomes k squared minus k, and k squared minus k is just k squared minus k plus 3k is plus 2k. Instead of writing it as k squared plus 2k, I'm going to add 1. Let me add 1 in a different color so you can see that it shouldn't have been there, but we put it there. We're going to add 1 and subtract 1. You might say, sir, that's crazy. And say, that's not crazy because that's what's going to give us a result. So this is now k plus 1 over 3. But this part that is k squared plus 2k plus 1, that part is now k plus 1 all squared minus 1. And we get what we're supposed to get now. Nice. So this gives us the result we're supposed to get. And so hence n equal k plus 1 is true. Hence n equal to k plus 1 is true. Since n equal k plus 1 is true, we can finally conclude, hence by PMI, the statement given is true for all natural numbers. So we've proven it now. Nice. Soft. Alright. Oh, okay. Finally, we get to module 3. We get to the nicest module in unit 2, which is module 3. So getting to module 3, it says, how many numbers made up of 5 digits can be made from the digits if each number contains exactly one even number and no digit is repeated? So it must contain one even number and no digit is repeated. All right, so first thing I like us to do is underline the critical information. You want to make a 5-digit number and it needs to contain exactly one even digit, and no digit is supposed to be repeated. So if it contains one even digit, that means we need to choose a 2, a 4, a 6, or 8 after the name and the number. So let's look at those different cases. So let's go with case 1, that the even number is 2. So let's go with case 1, the even number is 2. In case 1, if the even number is 2, you have 5 digits, 1, 2, 3, 4, 5. All right, if the even number is 2, you must choose 2. So it don't matter which part you put the 2, 2 just there in the number, right? So I'm going to say we already take out the number 2. So that's one number that we choose. Now there should only be one even number. So that means we cannot choose 4, we cannot choose 6, we cannot choose 8. So that left us with 1, 3, 5, 7, 9, 5 other numbers to choose from. So because we have 5 other numbers to choose from, right, it's going to be 5 times 4 times 3 times 2. All right, so this number right here, if I were to put it, this is number 2. All right, if we take number 2, then the 5 numbers that we can choose from right here is either 1, 3, 5, 7, or 9. Those are the 5 numbers we have what we can choose from. All right, these are the 5 numbers left, because we definitely cannot choose 4, 6, or 8. All right, that's why. And so in this case, for case 1, as you realize, in case the even number is 2, there's going to be 5 factorial ways. 5 times 4 times 3 times 2 times 1 is 120. So there's 120 possibility. Let me see. 5 ways to choose here. 5 times 4 times 3 times 2. 5 times 4 is, let me just put it in my calculator. 5 times 4 times 3 times 2 times 1. Yeah, that's 120. So there are 120 ways we can choose the number. We can choose a number 2 with 4 other digits. All right, nice. Now let's look at case 2. Case 2 is when we choose a different even number. Let's say we choose number 4. Case 2, we choose the even number 4. Since we choose the even number 4, right, 4 is the only even number that will be there. In case 2, you choose the even number 4. So that one put on already. So since you choose 4, you can't use 2, you can't use 6, you can't use 8. So you're left back with either to choose from 1, 3, 5, 7, and 9. So there are 5 ways you can choose the next number. 5 ways. Then there are 4 ways the third number. Then there's 3 ways. Then there's 2 ways to choose the last number. This is still 5 factorial again. That works out to be 120. So pretty much what that is telling me is all the 4 cases, I'm going to get 120. So case 4, case 3 rather. Case 3 is choosing the number 6, and that's going to be 120 as well. And case 4 is going to be choosing the even number 8, and choosing the even number 8, we're still going to get 120. So what does that mean? That means that adding up all of them is going to give us, so number of 5 digits with one even number is equal to, number of 5 digits with one even number is 120 times 4, which is, put that in my calculator, 120 times 4, 480. That's the number of 5 digits that we can get with one even number and no digits being repeated. Now it says determine the probability that this number formed is less than 30,000. If the 5-digit number is less than 30,000, that means the number either start with 1 or the number start with 2. Make sense? Okay, I can have a number like 12,000 something, or 20 something thousand, 15,000, 18,000, and something of that sort. And so let's look at case 1. Case 1 is where the 5-digit number starts with 1. So if the 5-digit number starts with 1, in case 1, the 5-digit number starts with 1, that means it will definitely choose 1. All right. The second issue is that it must have been an even number. So let's say the even number in this case is 2. Let's say we choose the even number 2. So there's only one way we can choose the even number 2. So that means we can't choose number 2. We can't choose 4, 6, or 8. And so if we can't choose 4, 6, or 8, then we're left back with, remember, you know, we choose number 1 is taken out already. We're choosing the even number 2, and so we can't use 4, 6, or 8. All right, so those are 5 numbers gone. We're only left back with the other numbers to choose from. So we have the number 3 can choose from, 5, 7, 9. All right, because we cannot, 1 already gone, 2 already gone, and we cannot choose 4, we cannot choose 6, we cannot choose 8. So we're left back with 4 numbers can choose from. And then right here, so we're gonna have 3 numbers can choose from. Then the final digit, we're gonna have 2 numbers can choose from. So 4 factorial, that's 24 ways. That's 24 ways we can choose a number 1 with the even number being 2. Now let's look at what if we chose the even number to be 4, right? All right, so this was a case where the even number was 2 and we start with 1. This was the even 2. What if we wanted the even number to be 4? If the even number is 4, we're still starting with the number 1, which there's only one way. And if the even number is 4, then it wouldn't be 2, still one way. And if we choose even number 4, we're still left back with 4 other numbers can choose here, 3, and 2. Nice, so this is what we have. So it's still 4 factorial, which is 24. So pretty much what I'm getting then is when the even number is 6 and when the even number is 8, you're still gonna get 24 and 24 ways. So that's for case 1. All right, now let's look at case 2. Case 2 is if the numbers start with 2. So case 2 is that the 5-digit number starts with 2. If the 5-digit number start with 2, then that means we can't use any other even number. So the 5-digit number start with 2. There's only one way that can go. One way, it start with 2. Then that means we have 2, 4 out, 6 out, 8 out. All right, and so we're left back with 5 other digits can choose. 5. Then 4 digits can choose here. Then 3 digits can choose here. 1, 2, and then 2 digits can choose here. So this equals 5 factorial, which is 120. So finally, the probability that the number chosen above, that the number is less than, let's say 30,000, that's what they want. The probability that the number is less than 30,000 is going to be equal to the total amount of numbers less than 30,000, which is 24 plus 24 plus 24 plus 24, which is 4 times 24 plus 120. And this is being divided by 480. And this is divided by 480. So you work that out now. So 4 times 24 plus 120 divided by 480, that's 0.45. That's the probability. So there's a 45% chance that the number is going to be less than 30,000. 45% of the time. Nice and easy, soft. So there's a 55% chance the number is going to be greater than 30,000. All right, part B. Part B says that A and B are 2 matrices that are given by or given as, okay, so given as this and this, and let's just get to the meat of the matter. They want us to find the value of x so that A inverse doesn't exist. A inverse will not exist if the determinant of A is equal to 0. So we need to set the determinant of A to the 0. The determinant of A is going to be using what they call this again, column. Using column 1, it's going to be 2 times 0, 2, 1, and 0 minus 3 times x minus 1, 1, let me see, cross this, so it's 1, 0. Then we have plus 2 times and we cross this across this, we have x minus 1, 0, 2, x minus 1, 0, 2, and we'll set this equals 0. So we go ahead and we're going to work this out now. So working this out, what we're going to be getting is 2 times 0 times 0 is 0, minus 2 times 1 is 2, minus 3 times x times 0 is 0, minus 1 times 1 is minus 1, so it's minus 1, which is plus 1, plus 2 times x times 2 is 2x, minus 0, that is equal to 0. And so we go ahead and simplify. 2 times minus 2 is minus 4, minus 3 times 1 is minus 3, plus 2 times 2x is 4x, and that is equal to 0. And so what we're getting is minus 4 minus 3 is minus 7. So I'm getting 4x equals 7. And so x can equal 7 over 4. So just to finish it off, x is equal to 7 over 4. That is the value of x for which A cannot have an inverse. So just to check it again. Yep, that looks good. 0, 2, 1, 0, that's fine. This is x minus 1, 1, 0, that's fine. And this is x minus 1, 0, 2. So we're good here. Good. Now it says, given that the determinant of A, B is equal to minus 10, show that x is equal to 2. So first thing I'm going to do is I'm going to work out what is the matrix A times B. Well, we don't even need to do that. The determinant of A times B is then telling us that the determinant of A times the determinant of B is minus 10. So the determinant of AB, we can always remember that the determinant of AB is the determinant of A times the determinant of B. The determinant of A times the determinant of B is minus 10. Now, the determinant of A, if you were to write this as a formula, the determinant of A would actually be given by, this would have been minus 4. Determinant of A is given by minus 4. Going back around here, then it would have been minus 3, minus 4, minus 3. And going back here, it's going to be plus 2 times 2x, which is plus 4x. So determinant of A is given by -4 minus 3 plus 2x. All of this is going to be multiplied by the determinant of B. And the determinant of B we can find. Let's do it right here. Determinant of B would be 1 times 2, 5, 3, 4 minus 2 times let's go here now, cross this and this, we get 2, 5, 1, 2, we get 2, 5, 1, 2, we cross down this now, and we go here now, cross this, go here and here, and we cross this out, and we're getting 2, 3, 2, 1, so it's plus 2 times 2, 3, 2, 1. This is to find the determinant of B. So what this is working out to be is, we can work this out now. We're going to get 2 times 4 is 8. 8 minus 15 is minus 7. So this part works out to be minus 7. Then this part now works out to be 4 minus 5. 4 minus 5 is negative 1. And negative 1 times minus 2 is plus 2. And this part works out to be 2 times 1 is 2, minus 3 times 2, which is minus 6. So 2 minus 6 is negative 4. Negative 4 times 2 is negative 8. So what we're getting is negative 7 plus 2 is minus 5. Minus 8 is negative 13. This is minus 13. Nice and easy, that's minus 13. Now that we get minus 13 here, yep, so the determinant of B is minus 13. This is equal to negative 10. So this expression is really 2x minus, is it 2x or shouldn't it be 4x? 2x times 2, yeah, this was supposed to be 4x. This was supposed to be 4x. This was supposed to be 4x. So the expression is now 4x minus 7 times 13. So 4x minus 7 times 13. All right, I'm just going to put a bracket around it and put minus 13. That's equal to negative 10. So I'm going to divide through by minus 13. And I am getting that 4x minus 7 is equal to, and I divide through, I am getting, what's that? Minus 10 over, let's go again. When I add that, I will get this times this. If I were to expand it in, let's just expand it in. That would be minus 52x. Then minus 13 times 7, I think that's 91. That's plus 91. And that's equal to negative 10. I bring over the 91 by subtracting 91 from both sides. And I get minus 10 minus 91. That's minus 101. And that's giving me minus 52x. I divide through by 2, I'm getting 1 point something. What went off now? Is the determinant of A right? Just checking to make sure this is right. 2x, this is 4x. This is minus 1 is plus 1. Minus 3. This part is definitely minus 3. This time this is 0, 0, minus, minus 2. All right, where did we go? All right, where did we go? Just checking the determinant of A formula. We know it should have been, this is 2, AD minus BC, this is minus 2, that's minus 4. This part is now AD is 0, minus minus 1 is 1, minus 3, minus 4 minus 3 is minus 7. And this is 2x minus 0 times 2, that's 4x. That's 4x minus 7. This part is right. And check the determinant of B. The determinant of B, let's go again. Determinant of B would have been using column 1 is going to be 3. Using column 1 it's going to be 3, 4, 1, 2. Cross this, 3, 4, 1, 2. I see the mistake now. 3, 4, 1, 2. My apologies, right here. 3, 4, 1, 2. Something was off. Should have been 3, 4, 1, 2. Let's just check to make sure the others is correct. Using this 2, it would have been 2, 5, 1, 2, yes. And using the last one, it would have been, this here would have been 2, 5, 3, 4. Would have been 2, 5, 3, 4. How did I get these numbers? That's crazy. Have to be very focused. 2, 5, 3, 4. A lot of mistake was made there. Oh gosh. My gosh. Working out the determinant of B again. This would have been 6 minus 4, which is 2. That would have been 2. This would have been 4 minus 5. 4 minus 5 is minus 1. Minus 1 times minus 2 is plus 2. And this would have been 8 minus 15. 8 minus 15 is minus 7. Minus 7 times 2 is minus 14. So the determinant of B is actually negative 10. It's actually negative 10. The determinant of B is actually negative 10. All right. Determinant of B is actually negative 10. Okay. Now I can feel a little more relaxed now. This should be negative 10. And so I didn't need to do this step. I could just divide through by negative 10. Then I'm going to get 4x minus 7 is equal to 1. So divide through by minus 10, I'm going to get 4x minus 7 is equal to negative 10 over negative 10 is negative 10 over negative 10. So I'm getting 4x minus 7 equal 1. And if 4x minus 7 is equal to 1, then I can bring over the 7 to the other side. And from this, clearly, x will be equal to 2. Finally, nice and easy, soft. Nice question. Continuing. It says, hence obtain A inverse. It says hence, meaning given that you know this. Given that you know this, then what you do know is that if the determinant of B was 10, then we know that the determinant of A, we now know that the determinant of A is equal to 1. If the determinant of A is equal to 1, then what that means is, if the determinant of A is now equal to 1, then that can help us to find the value of x in this. Since the determinant of a is equal to 1, and that is telling us that 4x minus 7, which was, oh, we just found x now. We said that x was 2. And so since x is now 2, we now know the matrix A with the determinant being 1. And so now we know that A inverse is going to be equal to 1 over the determinant of A times the adjoint. So all we need to do is find the adjoint of A. And the adjoint is the cofactor matrix transposed. So I'm just going to write what was A again up here. I'm going to go look back and write down A around here. So we have it right here. So A was 2x minus 1. 2x minus 1. So A is 2x, which is 2 minus 1. And so the next was 302 and then 210. 302, then 210. So let's go ahead now and find A inverse. So it's going to be 1 over the determinant of A. A determinant of A is 1. 1 over 1 is just 1. So all we really need to do is find the adjoint. And the adjoint is the cofactor matrix transpose. I'm going to put T up here. We're going to find the cofactor matrix. Plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, nice and easy. So let's go ahead now and do this question. Going ahead and do this question now, as we can see right here, to find the cofactor for this element, it's 0, 2, 1, 0, 0, 2, 1, 0. Cofactor of this element will be 3, 2, 2, 0, 3, 2, 2, 0. And the cofactor of this element will be cross here, 1, 1. That will be 3, 0, 2, 1. Just want to make sure. 3, 0, 2, 1. Let's expedite the process a little bit. Cross here, we're going to get 2 minus 1, 1, 0. That's 2 minus 1, 1, 0. For this one now, it's going to be cross here, 2 minus 1, 2, 0. That's 2 minus 1, 1, 0. All right, going for the final one here, it's going to be cross here, it's 2, 2, 2, 1. So it's 2, 2, 2, 1. Down here now, it's going to be cross here, it's 2 minus 1, 0, 2. This is 2 minus 1, 0, 2. Going right here now, it's going to be cross here, it's 2 minus 1, 3, 2. It's 2 minus 1, 3, 2. And right here, it's going to be cross here. It's going to be 2, 2, 3, 0. 2, 2, 3, 0. The final one, 2, 2, 3, 0. I just want to check this one right here. Something look weird about the second one. Cross here. It's 3, 2, 2, 0. Just wanted to make sure. So now that we have the cofactor matrix, we can go ahead and simplify it. And so we're going to get that A inverse is equal to, working out this is 0 minus 2 is minus 2. This is now 0 minus 4, minus 4 is 4. This is now 3 minus 0 is 3. This is now 0 plus 1, and the minus of plus 1 is minus 1. Then we have 0 plus 1. Then we have 2 minus 4. That's minus 2, but minus 2 make it positive 2. Then we have 4 minus 0 is 4. Then we have 4 minus 3 is 7. Then the minus, that makes it minus 7. Then we have 0 minus 6. That's minus 6. And remember, we need to transpose it. Let's transpose it. So transposing it, we get that A inverse. Finally, we get that A inverse is going to be minus 2, minus 1, minus 4. And that's going to be 4, 1, minus 7, 3, 2, and minus 6. Nice. Okay. Continuing right along. Part C. Part C says, in an experiment, individuals were asked to select from 2 available colors, green and blue. The true individual selected 1 color, 2 colors, or no colors. 70% of the individuals selected 1 color, 600 individuals selected no color. All right. Now, if you are a person that like to think diagrammatically, or you like to see what's happening like myself, you could draw a set and you can say either you select this your color, or you select another color, or you select both colors. We can call the intersection for the amount of people that collect both color X. And it tells us that 600 don't select no color, so 600 don't select no color. The 2 colors are green and blue, so we can call one set green and one set blue. And it tells us that 600 people is 30%. So by calculation, 0.3 times the total amount of people is equal to 600. And so if you divide both sides by 0.3, that gives you the total population. And the total population in the school, if it's a school choosing colors, it's going to be X is equal to 600 over 0.3 is 2000. X is 2000. All right, nice. If X is 2000, that means that the universal set is 2000. And it said 70% selected at least 1 color, meaning that this total in here sum to 1400. That means 70% is 1400. All right, that means in here this sum to 1400. All right, so what they're telling you is 0.7 times X is 1400. All right, now next thing it tells us is that 40% selected green and 50% selected blue, meaning 40% of individuals selected green and 50% selected blue, meaning 40% of the total population, so 0.4 of 2000 selected green, and so 0.4 times 2000 is 0.4 times 2000, that's 0.4 times 2000, that's 800. So that means 800 minus X selected green only. And then the next thing is that It says 0.5 of the total population selected blue. 0.5 of 2,000 is 1,000. So 1,000 minus X selected blue. Now we need to find X to know what this intersection is. So you can go now and say that 1,000 minus X plus X plus 800 minus X, that is equal to 1,400, because the total amount in this set sum to 70% of the population. That's 1,400. Cool. So what that means is 1,000 plus 800 is 1,800 minus X, that's equal to 1,400. So that means that X equal 400. X equal 400. X being 400, what does that mean for us? X being equal to 400 means that 400 person, so X equal 400, that implies that 400 persons selected both colors. So figure out all of the information now and let's attempt the rest of the question. It says calculate the probability that an individual selected both colors. So the probability that you select two colors, probability that a person select two colors, well, that is just going to be equal to how much people select two color? 400 over the total school campus, which is 2,000. So 400 over 2,000, that will give you 400 divided by 2,000, that's 0.2. That's the probability of a person selecting both colors. Now you might say, sir, I didn't want to do it like that. That was too long. There was another way you could do it. Yes, another way you could do it is this. Remember the formula. The probability of green intersect red, it's equal to the probability of green plus the probability of red minus the probability of red intersect green minus the probability of red union green. You might say, sir, why you didn't do it like this? I could. So the probability of green intersect red would have been equal to the probability of green 0.4 plus 0.5 minus the probability of red union green, which is 0.7. That's what they told us. And you would get 0.2. So you might say, sir, why you never just do that from the start? No, this way it shows the examiner you understand exactly what you're doing. This way, it's just the formula. Come on, man. This don't show me that you understand nothing. This show me that you know what you're doing. Nice. Now it says determine the total number of individuals that participated. 2,000. We found that already. So this was 2,000 persons. We already show it around here. Nice. All right, we'll finally get to the best question on the paper. Question number 6, which is going to be differential equations. So this question says, a differential equation is given by x dy by dx plus y, and that's equal to 2 sine x. Show that the general solution to the differential equation y is equal to c over x minus 2x over cos x. Nice. Okay, let's go ahead and do this. Okay. X dy by dx plus y is equal to 2 sine x. So let's go ahead and do this nice and entertaining question. All right, so let's go ahead. Why is it not zooming? Having some difficulty here. Let's try that one more time. Okay, all right, finally. Now we may proceed. So to do this, first you want to divide through by x to get it in the form dy by dx. When you divide through by x, you're going to get plus y times 1 over x, and that's equal to 2 sine x over x. All right, and then what is the first thing you need to do? Find your integrating factor. Your integrating factor I is equal to e to the integral of 1 over x. E to the integral of 1 over x. When you integrate 1 over x, you get ln x, so it's e to the ln x. E to the ln x is just x. Nice. So what do you do next? You find your general solution. So your general solution now, let's call it GS. Your general solution is going to be y times your integrating factor x, and that's equal to your function of x, which is 2 sine x over x times x. 2 sine x over x times x, and we're integrating all of this with respect to x. Dx. Now the x times the x cancel. This cancel this. And so what you get is y times x is equal to the integral of 2 sine x. The integral of 2 sine x is 2, integrate 2 sine x. Integrate sine, you get minus cos. So it's going to be minus 2 cos x plus some constant c. Then all you need to do is divide through by x. Yep, so good. We divide through by x, and so this implies that divide through by x, we get y is equal to, let's start with the c part first. C over x minus, divide this part by x, we get minus 2 over x times cos x. Nice and easy, soft. So we'll finish that question now. There it is, nice and easy, soft. That takes care of this part, soft. It says now, hence, determine the particular solution of the differential equation that satisfies the condition y to be equal to 2 when x is pi. So y is 2 when x is pi. So that means that we're going to substitute y as 2 and x as pi. So substituting it, y is 2 and x as pi. Plug in x as pi, it's going to be c over pi minus 2 over pi times the cos of pi minus 2 over pi times the cosine of pi. That's equal to the cos of pi, the cos of 180, which is the cos of pi, and the cosine of pi is minus 1. So this becomes minus 1 times this, which is c plus 2 over pi And so c plus 2 over pi is equal to 2. We cross multiply to get 2 pi minus 2, and that's equal to c. So since that is c, therefore, what I'm going to do is factor out the 2. Let's write c as 2 times pi minus 1. This looks better. Let's write it in a prettier form as 2 bracket pi minus 1. So if this is c, what we're going to get is y is equal to c over x. So y is going to be 2 times pi minus 1 over x, 2 times pi minus 1 over x minus 2 over x cos x. Nice and easy, soft. All right, now part B. Part B says, show that the general solution of this differential equation is given by that. Okay, to do that question, let's write it down. We have dy by dx, and dy by dx is going to be equal to x times y. Dy by dx is x times y minus y over x squared minus 4. This is dy by dx. Nice. So let's cross multiply. Well, not cross multiply yet. Let's factor out y. We're going to factor out y, and what we're left back with is x minus 1 over x squared minus 4, and that is now dy by dx. And now what we're going to do is we're going to divide both sides by y and cross multiply dx. So what we're going to get is 1 over y dy is equal to cross multiply up dx, and we get x minus 1 over x squared minus 4 dx. Aha, now we can integrate both sides. But before we can integrate both sides, I can't integrate this like that. I need to rewrite this now. Instead of x squared minus 4, I'm going to write it as x minus 2 times x plus 2. I'm going to rewrite it as x minus 2 times x plus 2. But wait, I noticed that x minus 2 times x plus 2, and I have a x minus 1 in the numerator. I can separate this part using partial fraction. So I'm going to have to separate them using partial fraction. So let's separate them using partial fraction. Now, using partial fraction, we're going to get that x minus 1 over x minus 2 times x plus 2, separating using partial fraction. What we're going to get is that this is equal to some constant over x minus 2, some constant over x minus 2, plus some constant b over x plus 2. So since this is what we get now, what we can do now is separate them. We can separate them now to find a and b. Now the LCM would be x minus 2 times x plus 2 and so we're going to get a times, this is x plus 2, sorry, So we're going to get a times x plus 2 plus b times x minus 2 and that's going to be equal to, of course, x minus 1 over x minus 2 times x plus 2. Now, of course, when you get to this stage now, what you are going to have to do is equate the numerators. Whenever two fractions are equal, you equate their numerators. Equating their numerators, well, let x be 1. If we let x be 1, or let x be 2. If x be 2, 2 minus 2 is 0. And if x is 2, this is x minus 1. I'm writing rubbish here, trying to move a little faster. X minus 1, x plus 2. If we let x be 2, substitute 2 here, we get 2 plus 2 is 4. So we get 4a is equal to 1. And so that then tells us that a equal a quarter. A equal a quarter. And then if you make x be minus 2, you get minus 4b. You're going to get minus 4b is equal to x being minus 1. X being minus 2 rather. X is minus 2. We get minus 2 minus 1 is minus 3. So you have minus 3 is equal to minus 4b. And so that tells us that b is equal to 3 over 4. So that is b. b is 3 over 4. Since b is 3 over 4, we can proceed. So now what we're going to get is, continuing from right here, let me block it off. This is not necessarily part of the solution. This is just workings. So what we're going to say now is, this part where we have 1 over y dy, that part where we have 1 over y dy is going to be 1 over y dy is equal to, continuing, we have around here, x minus 1 over this is going to be a over this, and a over this is a quarter over x minus 2. So a quarter over x minus 2, I'm going to rewrite that as a quarter is 1 over 4 into x minus 2 plus 1 over, it's not 1, it's b, and b is 3/4 over x plus 2 dx. This is what we have now. Since we have all of this now, we could multiply through by 4, because I don't like the quarter thing. Let's multiply through by 4. I'm just going to multiply through by 4 to write 4 over y dy, and that's equal to, that's going to become now 1 over x minus 2 plus 3 over x plus 2, and it's all of this dx. So now that this is what we have, what we can do is now integrate both sides with respect to y. Integrate both sides with respect to y. Integrating both sides with respect to y, what you're going to get is 4 over y dy. When you integrate that, you can factor out the 4, and you're going to get 4 ln y you're going to get 4 ln y is equal to the integral of 1 over x is just ln x minus 2 plus, when you integrate 3 over x plus 2, you get 3 ln x plus 2 plus some constant of integration c. You get plus some constant c. But now look at this now. Instead of writing some constant c, I'm going to bring up the power of 4 and write this now as ln y to the 4 is equal to ln x minus 2. I'm going to bring up the power of 3 to write plus ln x plus 2 cubed ln x plus 2 cubed. And then this 3 right here, I'm going to put it as plus this c right here. I'm going to write it as ln a. Or let's write it as ln k. Let's write it as ln k. ln k is still a constant. C is just ln k. Now, by laws of logarithm, we can write these as 1 log. So we're going to write it now as ln log a plus log b plus log c is a log of abc. So this is now just a log of x minus 2 times x plus 2 cubed plus or times ln k is just times k times k. So now that I have everything as 1 log on that side, and that's ln y to the 4. Now apparently, well, the logs apparently cancel, or that's what they have been telling us, that logs cancel. And so the log cancel to leave that y to the 4 is going to be equal to y to the 4 is equal to x minus 2 times x plus 2 cubed times some constant k. Let's put the constant in front. So to find y, you just take the quart root. So taking the quart root, you're going to get y is equal to the quart root of, put the quart root, so you put a 4 to show that it's a quart root. Y is the quart root of k times x minus 2 times x plus 2 all cubed. That's how you do this question. Nice and easy and simple and soft. That is why. Nice. Soft. Well, the k is on the outside right here. So what you can do is use surds and break up this as the quart root of k times the quart root of this. Since that's how they want their answer, we can break this up then as the quart root of this, the quart root of this, times the quart root of our k, times the quart root of our k. All right, and then this quart root of our k, we can just call that answer some small k. All right, so now this is just some small k. This is capital K, this is small k. And so y is now k times, because it's still a constant. Quart root of k or k still a constant. So y is just now k times the quart root of x minus 2 times x plus 2 all square. Nice and easy, soft. Nice. Proven. Now part C. Part C says solve the boundary value problem. It says that y double prime minus y prime minus 2y. Solve that boundary value problem. Now to solve that problem, 10 marks. Whoa. To solve this boundary value problem is 10 marks. Now to solve this problem, first we need to do is solve the auxiliary equation. Its corresponding auxiliary equation, I like to call auxiliary equation AE. The corresponding auxiliary equation will be u squared minus u minus 2 is equal to 0. And then you go ahead and factorize this. You go ahead and you factorize it. And so you get u. Solving this characteristics polynomial has to be 2 and 1. Signs are different. The greater product negative, so minus and plus. So what you're getting is u is equal to minus 1 or u is equal to 2. U is either minus 1 or u is 2. So since this is what we get now, so the general solution, which is our complementary function, I like to call it YC. So the general solution is going to be, because we get two different roots, it's going to be AE to the minus 1 times x, which is minus x, plus BE to the 2x. But the thing is, we need to find A and B, because they said given that when x is minus 1, y is 1. So when x equal minus 1, what we're going to get is y is 1. So putting y as 1, we're going to get 1 is equal to A. And they say x is minus 1. So minus 1 is 1. So you get A e to the 1. So you get AE. Minus 1 is just 1. So you get AE plus. X is minus 1. So you get BE to the minus 2. BE to the minus 2. All right. So you get one equation. This is when x is minus 1. That's one equation. Now when x is 1 now, so when x is 1, we're going to get a different equation. When x is 1, y is 0. So you're getting 0 is equal to, put x as 1 here. So you get x is now 1, you get AE to the minus 1. And then x being 1 here is also 2 times 1 is 2, so plus BE to the let's go, BE to the x as 1 here too. So we need to solve these two equations for A and B. All right, so to solve these two equations for A and B, this is what we're going to be solving, these two equations. So let's see the easiest way to do this. The easiest way I'm seeing is if I to make A the subject from, let me see, make A the subject from here. All right, let's make A the subject from this one. From this one, I'm going to make A the subject so I can use substitution. I'm going to get 1 minus B E to the minus 2 over E. That's going to be equal to A. That's what I get when I make A the subject from here. 1 over E, we can say that is E to the minus 1. 1 1 over e is e to the minus 1 minus b e to the minus 2 over e is b e to the minus 3. That is a. So a is e to the minus 1 minus b e to the minus 3. Substitute that in here for a now. So I'm going to plug it into this equation. And so the output it's going to give me now is, substituting it now, I'm going to get 0 is equal to e to the minus 1 minus b times e to the minus 3. And this is being multiplied by e to the minus 1 plus b times e squared. So this will allow me to solve for b. So now expand this now, e to the minus 1 times e to the minus 1. When you work that out, you're going to get, when the bases are the same, you add the powers. Minus 1 plus minus 1 is minus 2. So I get e to the minus 2. Then I add the powers again, minus 1 plus minus 3, I get times be to the, adding the powers, minus 3 plus minus 1 is minus 4, plus be squared. All right, so I'm almost finished. We are almost done. What we can do now is bring over e over here to get, we're going to carry over. So let me just write back the equation. We have 0 is e to the minus 2. 0 is equal to e to the minus 2. And we had minus be minus be to the minus 4. And we have plus be squared. All right, so let's go now. So let's go. We need to make b the subject. So bring over this to get minus e, the minus 2. Then we're going to factor out b from this side. Factor out b. We're going to be left back with e squared minus e to the minus 4. Then we divide both sides by that, and so this implies that b is going to be equal to minus e to the minus 2 over e squared minus e to the minus 4. Because I don't want the minus in the numerator, I'm going to put it in the denominator. So I'm going to rewrite it as e to the minus 2 over e to the minus 4 minus e squared. I just put the minus in the denominator. Now since this is b now, I already had a formula for a. So a is going to be equal to, going back around here, we said a was 1 minus b, a was e to the minus 1 minus b e to the minus 3. So a was e to the minus 1 minus b e to the minus 3, which is minus, this is b now, e to the minus 2 over e to the minus 4 minus e squared times e to the minus 3. That is a. And so what you can do is, since the bases are the same, we add the powers to get e to the minus 1 minus, this will become e to the minus 3 times e to the minus 2 is e to the minus 5 over e to the minus 4 minus e squared And so you can make it one fraction now. Make it one fraction by multiplying this times e to the minus 1. So when the bases are the same, you add the powers. Making it one fraction, you get e to the, add the powers, minus 1 plus minus 4 will be minus 5. So you get e to the minus 5, e to the minus 5. Add this power, minus 1 plus 2 is plus e to the 1, minus e to the minus 5 over e to the minus 4 minus e squared. Now you might take a look at it and say, oh, e to the minus 5 cancel e to the minus 5, you're right, and e to the 1 is just e. So a is e over e to the minus 4 minus e squared. Now, I don't know how you prefer to write it. So if you like this as a decimal, you can put these as decimal. Just put it in a calculator and write them as decimal. You can write them as decimal. Putting this as a decimal, it is e to the minus 4 minus e squared. And then e divided by that. In this, I'm getting minus 0.4 or 0.37. And up here, I am getting e raised to the minus 4 minus e squared, and e raised to the minus 2 divided by the answer. I'm getting minus 0.01 for B. I'm getting minus 0.01. Minus 0.018. And this was actually minus 0.37. So depending on how you want to write your answer, if you want to write them as decimal or as a whatever, up to you. I like to write it exact, so I'll work with the exact form. And so now remember the solution was ae to the minus x. So finally we're going to write the solution. So we're going to write the solution right here. So y, which we know was ae to the minus x plus b e to the 2x. Tell them that this is question number 6. That's going to be equal to what we said was a, this was a, and this is being multiplied by e to the minus x. Since the denominators are the same, look what I'm going to do. I'm going to factor out this denominator. So I'm going to write it as 1 over e to the minus 4 minus e squared into, I multiply now e, because I have e over this, I multiply e times e to the minus x to get e to the 1 minus x. That's what you get, e to the 1 minus x. Plus, go ahead now, and you multiply b now, e to the minus 2 times this will become, e to the minus 2 times this will become e to the 2x minus 2. So this is the solution. That's the answer. Soft, a capital T. Tell them soft. Tell them soft. Too easy. Tell them soft, a capital T. Capital T. Soft. So this concludes 2019 paper. 2020 doesn't have any paper due to COVID reasons, but I wish you the very best practicing for your exam, and say it with me, K math is nice and easy, soft.